Alright, let's determine the equation of the tangent to the curve y is equal to 1 over the fifth root of 5x cubed minus 2x squared at x is equal to 2. So just off the bat, you guys can tell that you need to utilize chain rule for this. So to make my life easier, I'm going to change this reciprocal radical equation. I want to change it, well, this expression anyways, I want to change this into a power. So I'm going to rewrite this as 5x cubed minus 2x squared. Because it's a reciprocal, I'm going to be using the exponent rule. X to the power negative a is equal to 1 over x to the power a. So you can write this as negative to some kind of power, and because this is going to be a root, I'm going to use the rule x to the power a over b, which is equal to the index of b, the radicand x to the power a. So I'm going to put this to the power 1/5. Okay. So if you want to find the equation of tangent, we know that the slope of the tangent is basically the first derivative, so dy with respect to dx. Okay, so you want to find the derivative of this function. So when we do this, we get negative 1 over 5x cubed minus 2x squared minus 1 over 5 minus 1, which is negative 6 over 5. And then you want to utilize the chain rule where you do the derivative of the inside with respect to x, so you get 5x cubed minus 2x squared. Okay, so when you do that, you basically will get negative 1 over 5 times 5x cubed minus 2x squared to the power negative 6 over 5 times the derivative of this guy, which is going to give you 15x squared times minus 4x. Okay, and so this is your slope of the tangent, except you need to find your slope of the tangent at a single point. So I'm going to find this at x is equal to 2. So this is going to be your tangent at x is equal to 2. So when we let x equal 2, we're going to substitute 2 into all of these values. So you get negative 1 over 5 times 2 cubed minus 2 times 2 squared to the power negative 6 over 5 times 15 times 2 squared minus 4 times 2. Okay, so it is a little tedious. Okay, so I'm going to just kind of crunch all of this out. So this is negative 1 over 5, 8 times 5, 40, minus 2 squared is 4 times 2 is 8 to the power negative 6 over 5 times 15 times 4, that's 60, minus 8. So this is negative 1 over 5, 32 to the power negative 6 over 5 times 52. Okay, and if I crunch this out, well, you can notice here that this is negative 1 over 5 times the root of 5, 32 to the power 6. Okay, so it is a little messy in that sense, times 52, so I'm going to put 52 here. Okay, I'm going to crunch all of this out, and that's going to give me negative 52 times 5 times 64, which is negative 0.1625. Okay, so this is somewhat of an irregular number, but so this is the slope of the tangent. Now, using the slope of the tangent, we're going to plug this into our equation. Because the tangent is a line, we can use the equation y is equal to mx plus b. So y is equal to negative 0.1625x plus b. And you also need to substitute a point to solve for b, which is also known as the y-intercept. So to find the point, we know that x is equal to 2. Let's find its y equivalent. Okay, so let's pretend that this guy here is f of x, right? And we're going to plug in x is equal to 2 into the equation to solve for a point of y that we can plug in. So when we do that, f of 2 here is equal to, I'm just going to call this guy f of x for the time being, it's the same thing. You get 1 over fifth root 5 times 2 cubed minus 2 times 2 squared. Okay, and this is going to give you 1 over fifth root of 40 minus 8, which is 1 over the fifth root of 32, which we know is 1/2. Okay, So the equivalent point here is 2 1/2. Okay, and we're going to substitute 2 1/2 into the equation. So if I substitute 2 1/2 into this equation, we basically get 1/2 is equal to negative 0.1625 times 2 plus b, and b here is equal to, if I move this to the other side, 0.5 plus 0.1625 times 2, 0.825. Okay, so this gives us the equation of the tangent, which is y is equal to negative 0.1625x plus 0.825. Okay, and that is the equation of our tangent.